Hello, my name is Sukaina, and in this video, my friends and I will be talking to you about the effects of temperature on methylene blue's diffusivity. I'm going to start by giving you an overall introduction. What is diffusion? Diffusion is the net movement of molecules from a region of high concentration to a region of lower concentration due to a gradient. This gradient can be a gradient of temperature or pressure or many others, but the focus of this project is to study the effect of difference in temperature on the diffusivity of methylene blue in water. This experiment is carried out by, first we prepare water samples at different temperatures, and then we immerse a sample of methylene blue of fixed concentration into water, and then over time we take samples and measure the absorbability over time. For the apparatus, the material used is the water, methylene blue and gauze. Lab equipment is 2 beakers, pipettes, heating mantle, thermometer, and UV visual spectroscopy. And then now my friend Anas will be talking to you about it.
Hello everyone, and as my teammate Sukaina mentioned, I'm going to talk about the methodology section of our project. Now, the methodology section consists of 2 parts. The first part talks about the sample collection and the second part talks about the calibration process. Now, regarding the first part, the first step is to prepare a stock solution of methylene blue. And this is basically done by measuring 99.8 milligram of methylene blue and placing it inside a 1 liter flask and then filling this flask with water until we have a total of 1 liter solution. After that, we're going to take 2 200 milliliter beakers and we're going to fill them twice. Once we're going to fill them with water at room temperature and the second time with water at 55 degrees, which is basically water heated using the mantle. After that, we're going to take gauze pieces and we're going to place them inside the stock solution, in the methylene blue stock solution, and we're going to wait for around 10 seconds so that it basically absorbs some methylene blue. After that, we're going to take it and going to place it inside the water sample and wait for it to diffuse. After that, we're going to take the pipette and we're going to place it always in the same area in the water sample so that we ensure accuracy, and we're going to take a sample every 2 minutes. And this sample we're going to place it inside the cuvette. And basically the cuvette is important because later we're going to place it inside the UV as we have previously shown in the apparatus. And now I'm going to leave you for the second part in which my teammate Jumana is going to discuss the calibration process.
Hello everyone, my name is Jumana Zghayar and I will continue after my teammate Anas who talked about samples collection, and I will be talking about the calibration process. This process is very important because it lets us fit our unknown concentrations on an equation with the help of known concentrations. So we need 5 fixed known concentrations to establish this linear calibration curve. And we use the equation C0 V0 equals CI VI, and CI VI represents the wanted concentration, which are 0.51, 1.52, and 2.5, and VI is fixed at 20 milliliter, and C0 it's 99.8 ppm, and our unknown is V0. The volume that we need to take from the stock solution to prepare the 5 fixed concentrations. So we add the 5 fixed concentrations to the 20 ml flask and then we fill it until we reach the 20 ml with water. So it should be 20 ml water and from the stock solution. And then we put the samples in the cuvettes, in different cuvettes to be used in the UV vis. And now we'll go to our section of using the UV vis. We had our samples collected and now we have our cuvettes, our 5 cuvettes of the fixed concentrations. And now we'll use the UV vis. First of all, we have to zero the UV vis with an empty cuvette, a full cuvette with water, filled with water, transparent, so that we can have the UV vis zeroed. And then we begin by our samples. We begin by our known concentrations and we will get their absorbability. And then our sample collection, we will measure each cuvette and get its absorbability. Everyone, and now I will leave you with my colleague Ahmed to talk to you about the results.
Hi guys, my name is Ahmed and I'll be discussing the results and the discussion of our experiment. So by now we have prepared 16 different samples of our solutions. 8 of them were taken from the beaker at room temperature and the other 8 were taken from the beaker that was heated to 55 degrees Celsius. These 16 samples were used in the UV vis to get the absorbivity of each sample. And then, by using the calibration process that Jumana discussed, we've constructed a calibration curve of absorbivity versus concentration, which turned out to be linear with a regression of 0.97. So this enabled us to use this linear equation to get the concentration for each of our 16 samples. Then we've used this data to construct another diagram of concentration versus time for each of our temperatures. And from the diagram, we can conclude two things. The first being that at a point of time, we can see that the concentration at the higher temperature beaker was much higher than the concentration at the room temperature beaker. We can also conclude that the concentration gradient over time and the diffusion rate was much higher in the hot temperature beaker. And this actually supports and confirms our observation when we were doing the experiment, that we saw it was very obvious that the diffusion rate was much higher in the hot temperature beaker. And doing the experiment, we have three limitations. The first being that we can't guarantee that every piece of gauze will actually absorb the same amount of methylene blue. And that was tackled by actually dipping the piece of gauze for 10 seconds for each sample to reduce the errors. The second being, while actually collecting the samples using the pipette has to be placed in the same exact position every time, because the diffusion is not uniform all over the solution. And also the third point is that the temperature of the hot beaker was fluctuating between 50 and 60 while taking the samples. That's why we assumed an average of 55 degrees Celsius. Now we will be going to the lab to show you how the experiment was actually performed. Thank you.
Hello, I'm Amin, and I'm going to show you how to do the experiment. First, we're going to prepare the stock solution. For that, we weigh 99.8 milligram of methylene blue dye. Then we add it into the flask, and then we fill it up with water until we reach a total volume of 1 liter. Okay, so now we've got the stock solution ready. What we're going to do now is prepare the samples. For that, we need a pipette, 200 milliliters of room temperature water, gauzes, and a small beaker. What we're going to do now is add some stock solution into the beaker. Next, we're going to put in a gauze into the dye, into the stock solution. We're going to leave it in for 10 seconds. So, done. We're going to get the gauze, put it into the room temperature water. So, the next steps are to take samples every 2 minutes. We're going to leave it for 60 minutes in total, and every 2 minutes we're going to take samples with a pipette. 2 minutes have passed. We're going to take the sample now. It's important that we always put the pipette in at the same location and at the same depth. We're going to put it into the cuvette. We're going to repeat the whole process every 2 minutes for a total of 60 minutes. After this, the same procedure will be repeated for a beaker with hot water at a temperature of 55 Celsius. In order to know the sample concentrations, we need a calibration curve. For that, we diluted our stock solution with water and got 5 known concentrations. Those 5 mixtures we measure in the UV-vis and obtain the calibration curve, absorbivity against concentration. With this calibration curve, we can know the concentration of the samples. Here we have the room temperature samples, the hot temperature samples, and the 5 known concentrations. Additionally, we have pure water, which we use to zero the UV-vis before carrying out the measurements. The obtained data you can see in the poster.
Thank you!